Hi, a day or two ago I received my RasPiO ProHat Kickstarter reward together with an experimenter's kit containing various electronic components, and in addition an 8-channel digital to A converter chip which can be used on the breadboard of the RasPiO ProHat. I thought about what type of project to try it out, and I decided that I would look at producing a LED bar graph which I could drive with some audio from Sonic Pi. The experimenter kit came with 5 LEDs, and I managed to fit 4 of them onto the board, each of them driven by a separate GPIO I/O input, and also to use a couple of extra components, 2 10 microfarad capacitors which you can see here, and in addition a lead which I cut from an old audio connector lead off an old computer, which has a 3.5mm plug on one end, and I chopped it in the middle, and the 2 connections are connected into the board here. Now this is going to provide the audio input, which is going to come from the Sonic Pi audio output here, which I fed to a splitter lead, one part of which is going to go via that green connector to an amplifier, and the other section which I'm going to plug in the lead from the circuitry here. So that is going to feed some audio into the board here and through the 2 capacitors to a resistor which is connected to the input of the ADC converter here. So we're going to be putting some audio into that, and I've got a little Pi program which is ready to go. And if I lift up the camera and just look up at the monitor here, you can see various things on that. First of all, we're running Sonic Pi, and I've got one of the example programs, Compass Beats, loaded in here, ready to play. Here's the program sitting in the Nano editor, and we'll have a look at that a bit later on, and a separate window down here which is set ready to run the Python program Sound LED Bar. So let me just press the enter key on the keyboard and we'll see what happens. And it says that it needs a sensitivity argument, for example sound LED bar.pi 40, try a range of say 30 to 100. The range isn't that critical, you can go a bit above 100, probably not much below 30 though. And so let's just do that, and if I come back to a previous run, we can see we've got sound LED bar pi 80 there, and if I press that, then the program starts running. It says the sensitivity is set to 80, and it asks me to adjust the potentiometer until all the LEDs are just out, and then start the music input. And when I finish with it, I can press Ctrl+C to exit the program. Okay, so that's ready to go. We'll just make the window here for Sonic Pi, the active one, so that I can run it from the keyboard in a minute, and we'll come down here and just focus on the LEDs down here. Now I've got a small screwdriver here, and what I'm going to do is to put it into the potentiometer, which is just lurking underneath the LEDs here, and if I rotate that, you can see I can turn all the LEDs on. Now if I rotate it very slightly clockwise, you can see that one by one we reduce the LEDs. First of all, the blue one dims, there it goes, then the green, then the yellow, then the red. It's not a very big range because we haven't got a very big audio signal coming in here, so the sensitivity control has given a fairly small range to this LED bar graph that we've got here. So I'm going to adjust the red LED so that it's just out, put the screwdriver down, and we'll now start Sonic Pi running from the keyboard, which is Alt-R, and here we go. And you can see the LEDs responding to the audio input. They're responding to the amplitude. You'll also get effectively a frequency response because as the signal varies, they dim in and out. The blue one is responding to peak signals, the green to slightly less, the yellow to slightly less, and the red to any signal whatsoever being picked up. You can adjust the sensitivity of the thing by setting the sensitivity value as we saw when we started up the program, or by coming up and just adjusting the volume of the Sonic Pi output. If I make it a bit smaller, then you can see we can actually cut everything out. If I increase it and get just getting hardly anything happening, have a bigger signal, then we get back to all 4 LEDs going again. We'll stop that playing and I'll just switch to another Sonic Pi program which I've got on here. This is one that I transcribed for Sonic Pi a couple of years ago, Scott Joplin's Maple Leaf Rag, and it's a nice piece to do because it's very percussive and the leads respond well to it. So here we go. So it'll work pretty well with basically any piece you play from Sonic Pi. As I say, something that's fairly percussive like this will work better than a very smooth piece where the amplitude is going to be more constant. Well, that goes on a bit, so we'll stop it playing and we'll come back up and have a look at the screen up here again. And what I'm going to concentrate on this time is if we just come down here and quit the program by pressing Control-C, you'll see that it says it's going to exit here, hopefully, if I can get it right. Get the window active first of all by clicking on it, there we go. And then Control-C and we'll stop that running. It says exiting and finished. I put in some coding, which is over and above the operation of the program, just to make it exit things properly rather than giving big long error traces there. And if we come here and we look at the top window, which is running the Nano editor, and that has got the program in it. And you can see some details about it here. I will be publishing this, so don't worry too much if you can't read it all here. But just to run through the program very briefly, we're using the GPIO 0 library, which has got most of the code that we need already written in it. It's got some code to deal with the MCP 3008 ADC converter. It's also got code to generate the LED bar graph. All we need to do is to tell it how many LEDs and which pins they're connected to, and whether we want them to respond to a pulse width modulated signal or just to work as an on-off signal. We're going to use the time section of the sleep module in order just to slow things down a bit. And from the sys module, we're going to use a couple of things to get the argument, the number we type in when we start the program, and also to exit the program cleanly. And this little bit, there's just a little error checking to see that we have actually typed in a number, which will go into what's called the arg vector, the second entry. And if it's not there, it just prompts us to do that and then quits the program using that exit command. Otherwise, it's going to set the sensitivity to the integral value of the number we type in. It then gives us the instructions on the screen, and we go on to start the program proper. The input is going to come from the MCP 3008 channel 0, and that's read automatically for us by the GPIO 0 library. We've got 4 LEDs, yellow, green, blue and red, which are attached to 4 GPIO pins. And then the whole program is essentially down to one line, which is the line that says graph equals LED bar graph, red, yellow, green, blue, PWM equals true. And that simply tells us which LEDs and in which order they're going to be used. So red for the lowest signal, blue for the highest, and we want them to gradually fade in and out with pulse width modulation. Then we get our main loop. We've got a try and except around it so that we can use the keyboard to interrupt the program nicely. And the while loop is just going to trundle around that again and again, and it's going to first of all read the reading from the ADC input and subtracting half from it, so that when we've got 0 signal, we've got the potentiometer roughly about mid-scale, and we're multiplying the difference, which is going to be due to the audio, by the sensitivity value. And then we're simply going to feed that into the graph value, and we've got this command around it, rather strange command, max open bracket 0, min brackets 1, v. And it explains in the comments there that these are just there to effectively put limits on the size of the value, so that it won't go above 1 or below 0. Because if we do, then the graph function is going to object, because those are the limits that it will take. And then the rest is to do with exiting the program. So we see there quite a nice little project using 4 leads, all the bits from, quite a lot of the bits from the experimenter kit, the only 2 additions, I say, being the 2 10 microfarad capacitors, and their value is not too critical. I have tried down as low as 0.1 and slightly higher values as well, but that's probably a reasonable sort of median value to use. So we'll just play you out with the Scott Joplin again, and we can do that by just restarting the program, which I'll hurriedly do over here, and then starting Scott Joplin. Here we go. Thank you for watching.